students, in the previous lecture I have discussed about decision making without probabilities. In this lecture I am going to discuss about how to make a decision when the probability is given. What is the meaning of probability? Here probability for our states of nature. After that I am going to discuss about the expected value of perfect information. What is the meaning of perfect information here? If somebody is going to give the states of nature, so what is the value of that information? After that I am going to discuss about the risk analysis for the decision making. So, the agenda for this lecture is decision making with probabilities and finding the expected value of perfect information, finally the risk assessment. In many decision making situations, we can obtain probability assessment for the states of nature. When the probabilities are available, we can use the expected value approach. You might have known, you might have studied this expected value approach, nothing but the mean value, weighted mean value approach to identify the best decision alternative. So, when we say capital N is the number of states of nature, in our problem 2, the PSJ represents the probability of states of nature. Here J, there is a possibility of strong demand and weak demand. So, what are the properties? The value of probability should be greater than or equal to 0 for all states of nature. The other property is the sum of probability should be 1. So, what is the meaning of expected value for different decision alternatives? The expected value is nothing but the probability multiplied by corresponding payoff for all states of nature. For example, the probability for strong demand is 0.8 and the payoff is 8. So, multiply 0.8 multiplied by 8. The probability of weak demand is 0.2, the payoff is 7. So, when you multiply this, so we are getting 7.8. So, expected value of decision 1 is 7.8. Expected value of D2, that is going for medium complex size, 12.2. Expected value of D3 going for large complex, 14.2. So, what is the difference between decision making without probability and decision making with probability? In the previous lecture, this 0.8 and 0.2 is not given, but now the probability is given. So, we are finding the expected value. So, out of these 3 expected values, which is the highest one? The highest one is D3. So, we are suggesting to go for large size complex. So, how we are doing this? So, this is 8 multiplied by 0.8 plus 7 multiplied by 0.2. Here 14 multiplied by 0.8 plus 5 multiplied by 0.2. Here 20 multiplied by 0.8 plus minus 9 multiplied by 0.2. So, we got the values. So, what are the values? For first one it is 7.8, for second one it is a 12.2, for third one it is 14.2. So, out of these 3, so this value is the highest one. So, we go for this one D3. Here I have shown how we got this 7.8, nothing but this 0.8 into 8, 0.2 into 7 and 0.8 into 14, 0.2 into 5. So, we got this 7.8, 12.2 and 14.2. Our suggestion is to go for large size complex. Now, we are going to find out the another term called expected value of perfect information. What is the meaning of this perfect information? Suppose that the company has the opportunity to conduct a market research study. So, the company is going for market research study that would help evaluate buyers' interest in condominium project and provide information that the management could use to improve the probability assessment for the states of nature. The company has assigned a marketing company. So, they were doing some market research study. So, they are going to provide the information about the states of nature. To determine the potential value of this information, what is that information? What is going to be states of nature? So, we begin by supposing that the study could provide perfect information regarding states of nature. So, we are going to find out what will be the value of this perfect information about the states of nature. So, the marketing research company, they will provide the demand is going to be strong demand or weak demand. That is, we assume for the moment that the company could determine with certainty, that is with the help of this marketing research company, that is prior to making decision which states of nature is going to occur. To make use of this perfect information, we will develop a decision strategy that the company should follow once it knows which states of nature will occur. What is a decision strategy? A decision strategy is simply a decision rule that specify the decision alternative to be selected after a new information becomes available. Here new information about the states of nature. Note that if the company knew for sure that the state of nature S1 would occur, the company say with the help of marketing research company, the states of nature is going to be strong demand. So, what will be the best decision alternative? So, if the company says this is going to be states of nature, our best decision alternative is D3, that is $20 million. Similarly, if the company knew for sure that the states of nature S2 would occur, the best decision alternative would be D1. So, if the company knows in advance states of nature is going to be weak demand, so we will be going for this one, that is a payoff of $7 million. Thus, we can state the company's optimal decision strategy with the perfect information becomes available as follows. If S1 is going to occur, select D3 and receive a payoff of $20 million. If S2 is going to occur, select D1 because this is the highest, D1 and receive a payoff of $7 million. So, what is the expected value of this decision strategy? As we know, the expected value is multiplying with the corresponding probability. So, to compute the expected value with the perfect information, we return to the original probabilities for the states of nature. We know that the probability of strong demand is 0.8 and weak demand is 0.2. Thus, there is a 0.8 probability that the perfect information will indicate states of nature S1 and the resulting decision alternative D3 will provide a 20 million profit. Similarly, with a 0.2 probability for states of nature S2, the optimal decision alternative D1 will provide a 7 million profit. So, the expected value of the decision strategy that uses the perfect information is multiplying this probability into 20 and 0.2 into 7, it is 17.4. Sometimes the student used to ask, when we know the perfect information, what is that? If the perfect information is, say, it is going to be a strong demand, why we have to multiply this 0.2? Because there are two possibilities. The marketing research company can provide two possibilities. They may say it is going to be a strong demand, at the same time they may say it is going to be weak demand also. So, in advance you may not know what is the suggestion of this marketing research company. So, you have to consider both the possibilities, but with the highest payoff, because we are know that we are know in advance this is going to happen. So, what you have to do, the probability with the highest payoff for one states of nature, for another states of nature probability with the highest payoff, when you multiply, this will be $17.4 million. Earlier in this section, we recommended decision using expected value approach is decision alternative D3 with an expected value of $14.2 million. Remember, we were suggesting when we go for expected value, our expected payoff was 14.2, because this decision recommendation and the expected computation were made without the benefit of perfect information. So, we did not consider the perfect information. So, $14.2 million is referred to as expected value without perfect information, because we are not knowing. So, this $14.2 million is expected value of without perfect information, EVWPI. Now, you should remember what is the expected value of with perfect information versus expected value of without perfect information. Just now you have seen the expected value with perfect information is 17.4 million and the expected value without perfect information is 14.2 million. The expected value of perfect information, now you see that we are finding the value of perfect information, EVPI, is the difference of these two. What is that? Expected value with perfect information, that is 17.4 minus expected value without perfect information, that is your $3.2 million. In other words, $3.2 million represents the additional expected value that can be obtained if perfect information were available about the states of nature. In other way, we can say the amount, the consultation fee which you can provide to the marketing research company should not exceed this $3.2 million, because by knowing perfect information, by not knowing perfect information, the difference is only $3.2 million. So, what is the expected value of perfect information is the difference between expected value with perfect information minus expected value without perfect information. Now, I am going to connect this expected value of perfect information with the help of this regret matrix. You remember, we have found the regret matrix, but we are going to multiply this regret matrix with corresponding probability. Regret is the loss. So, what will happen? The probability of strong demand is 0.8. So, 0.8 multiplied by 12 plus 0.2 into 0, 9.6. Expected loss, if you go for D2, it is 5.2. Expected loss, if you go for D3 decision, it is 3.2. Now, out of these three, which is minimum? the expected loss when you go for D3, that is 3.2. You see that our expected value of perfect information is equal to our expected loss of regret matrix. So, what we are saying that the expected loss of best decision is equal to our expected value of perfect information. So, regardless of whether the decision analysis involves maximization or minimization, the minimum expected opportunity loss always provides the best decision alternative. So, what I am saying that the minimum expected opportunity loss, whether the problem is maximization problem or minimization problem, if you go for minimum expected opportunity loss, that will always provide the best decision alternative. So, here the expected loss for D3 decision is 3.2. So, D3 is the recommended decision. In addition, the minimum expected opportunity loss always is equal to the expected value of perfect information. So, the expected loss of the best decision is equal to expected value of perfect information. So, in our problem this value is $3.2 million. Dear students, so far we have taken the decision based on the expected value. So, what is the meaning of this expected value? The expected value is nothing but your mean. We know that the mean many time, right, mislead the decision maker unless if you are not considering the standard deviation. So, what is the meaning of risk analysis? Risk analysis is when you take the decision, you should not look only for the mean, you have to consider the standard deviation also. So, the risk is measured by its standard deviation. So, risk analysis helps the decision maker recognize the difference between the expected value of a decision alternative and the payoff that may actually occur. The deviations, the deviation what you are expecting and what you are actually getting. So, that deviation is measured with help of the standard deviation. So, what we are going to do for each decision alternative, you see that we have recommended D3, right. So, for D3 decisions we are going to analyze what is the risk of that decision. So, a decision alternative and the states of nature combine to generate payoff associated with a decision. So, risk profile for a decision alternative shows the possible payoff along with their associated probabilities. Risk analysis. Let us demonstrate risk analysis and the construction of risk profile by returning to our initial problem. Using the expected value approach, we identified the largest condominium complex D3 as the best decision alternative. So, we consider only the expected value. We did not consider the risk, the standard deviation, the deviation from the what you expect and what actually is going to occur. The expected value of $14.2 million for D3 is based on a 0.8 probability of obtaining a $20 million profit and a 0.2 probability of obtaining a $9 million loss. The 0.8 probability for the 20 million payout and 0.2 probability for the minus $9 million payoff provide the risk profile for the large complex decision alternative. So, what is the risk profile? What is the risk profile is in x axis I am going to write the payoff, in y axis I am going to write the probability. So, minus 9.2 and 20.8. So, this is nothing but my risk profile. Now, look at the risk profile which is on the right hand side. So, now we know that for D3 decision the mean is 14.2. So, if I want to measure the risk, so what I have to do? I have to find out the standard deviation. So, for the standard deviation I have to know the value for variance. So, what is the formula for variance? The variance is x minus mu whole square p of x. Okay. In our problem, mu is our 14.2, the x is the our payoff, p of x is the probability. So, for the first one, if I expand this, minus 9 minus 14.2 whole square 0.2 plus 20 minus 14.2 whole square 0.8 . So, the students, if we quantify the risk of taking this decision, that is 11.6. Sometimes a review of the risk profile associated with the optimal decision alternative may cause the decision maker to choose another decision alternative, even though the expected value of the decision alternative is not as good. For example, the risk profile for the medium complex decision alternative D2 shows a 0.8 probability for a $14 million payoff and a probability of 0.2 for a $5 million payoff. So, if we find the risk profile for the D2, that is our second best decision, because no probability of loss is associated with decision alternative D2, the medium complex decision alternative would be judged less risky than the large complex decision alternative. Look at the D2 and D3. In D3 there is a chance for loss, but in D2 there is no chance for loss. So, we can say the D2 decision is lesser risky than the large size complex. So, as a result, the decision maker might prefer less risky medium complex decision alternative, that is D2, even though it has an expected value of 2 million less than the large complex decision alternative. So, here we know that it is a 12.2, this is 14.2. Even though the difference is $2 million, still some people may prefer medium size condominium. Now, we can quantify this one. So, first we have to draw the risk profile. As we know, what is the risk profile? So, it is 5, it is 14. So, 5 the probability is 0.2, for 14 the probability is 0.8. So, if we quantify this risk, so we know the mean is 12.2, as we know the formula for variance is x minus mu whole square p of x equal to 14 minus 12.2 whole square 0.8 plus 5 minus 12.2 whole square 0.2. So, first we have to find out the variance. So, the risk profile for the medium sized condominium. When we quantify this risk profile, we got the variance is 12.96 and the standard deviation is 3.6. So, this is your D2 decision. You see the D3 decision previously. Previously the variance was, the standard deviation was 11.6. So, when we compare 11.6 versus 3.6. So, 3.6 is the second best alternative, that is going for D2 decision is having less risky than the D3. Dear students, in this lecture I have discussed about decision making with probabilities. Otherwise, we can say decision making with risk. After that, I have discussed about expected value of perfect information. If somebody is willing to give the information about the states of nature, what will be the value for that information, that we have discussed. After that, we discussed about the risk of each decision alternative. So, we have studied that the importance of considering risk while making the decision. Thank you very much.